Hi everyone, I'm Braden and I'm part of Group 12 with Gil and Michael, and in this video we'll demonstrate our prototype model of the driving mate. Before we demonstrate anything, it's important to understand the problem our project intends to solve, and the importance of the problem. Our problem is when driving, sirens of emergency vehicles can be difficult to hear, particularly for those that are hard of hearing, and that the flashing lights aren't always visible. If we can solve these problems, we can improve the incident response time for emergency vehicles, we can reduce the risk on the roads for all drivers, and in some cases, reduce the learning curve for the hard of hearing learning drivers. Our solution is to provide an obvious and clear visual cue for drivers when an active emergency vehicle is nearby. We achieve this through the use of an LED indicator for the active emergency vehicle. I'll now hand you over to Gil, who'll talk more about our prototype design.
Thanks, Braden. On this slide is a photo of the prototype with its subsystems broken down. First, audio is captured via the microphone in block 1. The audio is filtered for less than 2 kHz and amplified in block 2. The analog signal is digitized in the ADC in block 3, and then the Raspberry Pi samples this and processes the digital audio through Fourier transforms and peak detection in block 4. If it identifies 2 consecutive matches, it sends an output to the LED in block 5. Here is a video of the prototype in action.
We have our driver mate prototype here with our microphone input over here, our LED siren detected indication over here, our Raspberry Pi at the back that's performing the sound processing. The speaker here is to simulate traffic noise and siren noise, and our console up here is displaying the output from the Raspberry Pi. So it's currently saying that it's not detecting a siren, and we can see that our LED indication is off. So I'll just introduce some traffic noise now. And we can just see it's detecting quite a lot of peak frequencies, but not detecting a siren. If I introduce a siren noise now, you see it's detected a match, our LEDs come on, and 2 successive negative matches means that our LED goes back off.
Thanks, Gil. Hi everyone, I'll be looking at the uses of DriverMate. DriverMate has been primarily designed for hard-hearing individuals and those experiencing some hearing loss from old age. It will provide a visual warning system to alert vehicle operators that emergency vehicles are present. However, with modern vehicles becoming more and more soundproof, all vehicle operators can benefit and are able to use DriverMate. In addition, autonomous vehicle manufacturers can also use DriverMate systems to help their vehicles better detect an emergency vehicle's presence. Autonomous vehicle manufacturers are constantly trying to make self-driving vehicles smarter, safer, and more aware. Combining a listening device that can hear sirens along with their cameras to see the lights will provide another level of detection far more accurate and reliable than just cameras alone. Currently, there are no devices on the market that can accurately listen for and detect emergency vehicle sirens. Although DriverMate was not designed for this purpose, the technology and software can easily be adapted for the use in autonomous vehicles. I will now show a demonstration of our DriverMate prototype in use. The scenario is of a person operating a vehicle with DriverMate installed on the dash. An emergency vehicle approaches and DriverMate alerts them of its presence. This scenario is representative of all vehicle operator users, whether they are hard hearing, have hearing loss from old age, or can hear well. As you can see, DriverMate is mounted to the dash of the vehicle. When it detects a siren, the light illuminates to warn the driver. The driver of the vehicle then pulls over to allow the emergency vehicle to pass. Once the emergency vehicle passes, the light goes out, and the driver continues his journey.
Thanks, Michael. Hi again, everyone. So, as you can see, our prototype does most of the functionality we want from this project. However, there are still some things left to implement and consider. Firstly, our siren code still needs tuning and testing to ensure accurate and consistent siren detection. We plan to add multiple LEDs to the design to indicate how close the emergency vehicle is by measuring the volume level. From both our feedback and testing, we found that the LED is quite bright at nighttime and can distract the driver, so we plan to add a day and night mode to reduce the LED brightness. This will be done through the use of a photoresistor. To make the design more functional, we plan to solder it to a prototype board and mount the driver mate inside a project box. This will allow us to separate the microphone by a cable. We have also considered the use of saving data in case you want to analyze the data when an emergency vehicle is nearby. This could be used by government bodies for road statistics or vehicle companies for safety research, as an example. We've also considered the use of an accelerometer for the same purpose, as another data point. Thank you for getting this far into the video. We hope you like the driver mate as a concept and can see its potential for use for many different vehicle-related applications.